In the diagram, ABCD is a quadrilateral with diagonal AC. Which of the following is a possible length for AC? So at first glance, you think, well, there's no right triangle here, and there's no angles, and do I use trigonometry, or do I use law of cosines? What do I do here? I don't know. I have to do it. I'm stuck, right? Perhaps, but some of you, of course, know this special formula called the triangle inequality. And that basically means that in any triangle, if you label the sides, say A, B, and C, A plus B must be greater than C, right? That's the only way a triangle can be made. So let's use that. AC is what we have to think about. So first I'm just going to look at this triangle right here. That means that 10 plus 9 has got to be greater than AC. So 19 has to be greater than AC. So since AC is less than 19, immediately I can get rid of that answer choice. All right. Now I'm going to concentrate on this triangle. In that triangle, any combination of this works, by the way. It doesn't have to be A and B. It could be B plus C has to be greater than A plus C has to be greater than B. Basically, two sides, when you add them, have to be greater than the third side. That's the only way a triangle can be made. So using that with this triangle, I will write that 5 plus AC, this side, the diagonal, must be greater than 19. Okay? That has to be true. So now let's go through the answer choices. If AC is 9, 5 plus 9, is that greater than 19? Well, no, because that's 14. 14 is not greater than 19. So that's no good. How about 10? 5 plus 10 is 15, and that is not greater than 19. How about 13? 5 plus 13, is that greater than 19? No, because it's 18, and 18 is not greater than 19. Well, there you go. By process of elimination, we boil down to 15, but 15 is indeed true, because if AC is 15, that means that 5 plus 15 is indeed greater than 19. So number 19, the answer is D. In the diagram, AB is 25, AC is 20, and angle A is 90 degrees. What is the area of triangle ABC? Area of a triangle is 1/2 base times height. The base in this case is AB, and they tell you that is equal to 25. And the height in this case is CA, and they tell you, or AC, and they tell you that is 20. So it looks like we've got 10 times 25, which is 250. So number 11, the answer is E. In the diagram, triangle PQR is isosceles, and PQ is equal to PR. What is the value of X? So if this is 95, this is going to be 180 minus 95, and that is 105. So put 105 in here. Sorry, 85. 85 goes in here. 180 minus 95 is 85. Okay, so if this is 120 right here, this is also 120. And then if I call this guy Y, this is also Y by opposite angles. So that means 120 plus 120 plus Y is going to be 360. So that means 2Y is equal to 120, and therefore Y is 60. So that Y is 60. So now if I call this, let's say Z, 60 plus 85 plus Z is equal to 180. So Z looks like it will be 35. And finally, because it's isosceles, this is also Z. So that means X plus Z is 180. And then X plus 2Z, and Z is 35, is 180. So that means X is equal to 180 minus 70. X is equal to 110. So number 20, the answer is A. In the diagram, triangle PQR has PQ equal to QR is equal to RP is equal to 30. Points S and T are on PQ and PR respectively, so that ST is parallel to QR. points V and U are on QR so that TU is parallel to PQ and SV is parallel to PR. If VS plus ST plus TU is 35, the length of VU is. Well, the fact that this is parallel and then this is parallel to that side means that these are similar triangles. These little guys are similar to the big guy. That's pretty much what they're getting at with that whole parallel stuff. All right, so let's label this now. They told me that the big triangle is equilateral, right? PQ equals QR is equal to RP. All right. PQ equals QR. Yeah, so that's equilateral. So that means if all of these are the same, then those little guys are also equilateral, these two, since they're similar. So I'll just call those sides X, like that. And therefore, the distance from V to U would be 30 minus 2x. And then, if you were to drop a perpendicular from S down to the bottom like that, and T down to the bottom like that, it would essentially chop the bases in half. So the distance, for example, from here to here would be x over 2. And the distance from here to here would be x over 2. Similarly, that would be x over 2. That's x over 2. So the distance S to T is 30 minus this x over 2 and that x over 2. So basically, it's 30 minus x. Okay, I think we have everything we need. Now we can use that piece of information. VS plus ST plus TU is 35. So VS I have labeled as x. ST I have labeled as 30 minus x. And TU I have labeled as x. And they told me that's 35. So when I solve this, I get x is equal to 5. All right, so my last step is to figure out the length of VU. VU is 30 minus 2x according to the labeling. So that's going to be 30 minus 2 times 5, which is 30 minus 10, which is 20. So number 20, the answer is 20, which is choice D. A line with slope equal to 1 and a line with slope equal to 2 intersect at point 1,6 as shown. The area of PQR is. Well, they give you the intersection point is 1,6. So one line will have the equation y equals m, let's say m1x plus b. And the other line will have the equation, let's say y is equal to m2x plus b. Well, actually, this should be b1 and b2 because those are probably going to be different. Well, we can substitute in the slopes that they give you. The first slope is 1, so this just becomes x plus b1. The second slope they tell you is 2, so this just becomes 2x plus b2. Now the point 1,6 is on both lines, so I can substitute that into both equations to solve for b. So the first one becomes 6 is equal to 1 plus b1, and therefore b1 is equal to 5. So that equation is y is equal to x plus 5. The next one, if I substitute 1,6, I get 6 is equal to 2 times 1 plus b2, and therefore b2 is equal to 4. So that means that equation is y is equal to 2x plus 4. So to get the area, I just have to now figure out the coordinates of Q and R. That will give me my base. Because the area, of course, is going to be 1/2 base times height. And the base is this distance right here from Q to R. So I'll just put that in there, QR. And then the height, we already know, right? Because if you were to drop a perpendicular from, say, P down to the bottom, like this, that represents the height. And that distance, we know, that distance is just the y-coordinate of P, which is 6. So the height is 6. All right, so to figure this out, we have to figure out where these lines cross the x-axis. So we just set y equal to 0. Setting y equal to 0 there, we get x equal to -5. So this is going to be -5 right here. setting y equal to 0 on this guy gives me negative 4 is equal to 2x, so that means x is equal to negative 2. So that means this point right here is negative 2. So the distance from Q to R is going to be 3. So there you go. You have 1/2 times 3 times 6, and that looks like 9. So the area of PQR is 9, therefore number 18. The answer is B. The line y is equal to negative 3/4 x plus 9 crosses the x-axis at point P and the y-axis at point Q. The point T, RS, is on the line segment PQ. If the area of triangle POQ is 3 times the area of triangle TOP, then the value of R plus S is. All right. So the first thing, of course, is we need to figure out P and Q, because those are obviously going to give us the area of that big triangle. And that's where that equation comes in. And this is really just figuring out the x and y intercepts. So first, find the y-intercept, set x to 0, and that quickly gives you y is equal to 9. So that means this is 9. So that this side is basically 9, QO or OQ, whatever. Now find the x-intercept, set y to 0, and you get the following. Bring the 3/4 over to the other side, and then x is therefore equal to 9 times 4 divided by 3, and that looks like 3 times 4, which is 12. So this distance is 12. All right, so the first thing I want to figure out is the triangle POQ area. 1/2 base times height, the base is 12, the height is 9, and that looks like 6 times 9, which is 54. All right, so they tell me that if I were to find the area of TOP, so I'll just make that triangle there, this is TOP, that is going to be related to the area that I just figured out in the following way, that POQ is 3 times the area of TOP. So that basically means that the triangle TOP, the area is 54 divided by 3, which is 18. All right, so now we have to figure out this area using our dimensions, and I'm just going to draw a height with that red line right there. So here we go. 18, which is the area of TOP, is 1/2 base times height. The base is this guy right here, 12, and the height, well, that is going to be represented in terms of either R or S. Which one? S, right? Because that is the top to bottom or vertical distance. Correct? So I've got S here, and that equals 18. So this looks like 18 is equal to 6S, and therefore S is equal to 3. All right, so we've got half the puzzle. So now we have to figure out R. How do we figure out R? Well, this point is on this line. So to figure out the other coordinate, plug it into that line. Y is equal to negative 3/4 x plus 9. We want to figure out R. S we already figured out was 3, so S represents the y coordinate, so put 3 here, correct? Minus 3/4, our x is actually represented by the letter R, so put that in there. And therefore, solving for this, we get 3 over 4 R is equal to 9 minus 3, which is 6, so R would be 6 times 4 divided by 3, and that looks like 2 times 4, which is 8. So finally, what they want is R plus S. So R plus S, 8 plus 3, and that is equal to 11. So number 20, the answer is C. In the diagram, triangle PQR is isosceles with PQ equal to PR and triangle PRS is isosceles with PS equal to SR equals X. Also, the perimeter of triangle PQR is 22. The perimeter of triangle PRS is 22. The perimeter of PQRS is 24. What is the value of X? Let's label these sides. We'll just call them, we'll call them Y. And then this is the only other side I need to label. I'll call that Z. Now let's look at the question information. PQR 22. So PQR. So that's 2y plus z is 22. PRS is 22. PRS. So that means this is x, right? 2x plus y is 22. And then PQRS, that perimeter is 24. So that's going to be PQRS. So y plus z plus 2x. That's 24. Okay. So this is the system of equations we have to work with and eventually trying to find the value of x. Okay. So let's see here. Well, y plus 2x is right here. So I can just substitute 22 for y plus 2x, and all I'm left with is z is 24. So very quickly, we get z is equal to 2. If z is equal to 2, substitute it in there. So I get 2y plus 2 is equal to 22. 2y is 20. Y is 10. Y is 10. Substitute that into there. And I get 2x plus 10 is 22. 2x is 12. And therefore x is equal to 6. So number 14, the answer is D. In the diagram, points R and S lie on QT. Also, PTQ is 62, RPS is 34, QPR is X. What is the value of X? A few different approaches to this question. I'll just do both, I guess. The first is to recognize that this is isosceles, right? That's what those two symbols mean. So if this is 62, then this is 62. Then what we can do is we can chop the triangle down the middle like this from P down here. Make that a right angle. So if that happens, then what you've done basically is you've cut this angle in half. So if it was 34 before, then we get 17 and 17 for this angle and this angle. Well, this is a right angle and this is 17. So now I can figure out this angle. Y plus 17 plus 90 is equal to 180 degrees. So that means y would be 90 minus 17, which is 73. And then if this is, say, z, we know that z plus y is equal to 180. So that means z is 180 minus y, and therefore z is 107. And then finally, x plus 62 plus z is 180. So that means we have x plus 62 plus z is 180, and z is 107. So x plus 62 plus 107 is 180. And then solving, we get x equal to 11, right? The other way to do it is to understand that this is a symmetric diagram. So if this is x, then therefore that is x. And therefore, these angles plus the two 62s must add up to 180. So that means 2x plus 34 plus 62 plus 62 is equal to 180. And if you do that, you get 2x is equal to 22, and therefore x is equal to 11. So both ways you get the same answer, and that answer is A for number 17. There is a square whose perimeter is the same as the perimeter of the triangle shown. The area of that square is. Well, first we need to figure out the perimeter of this triangle. Using Pythagoras, you can easily figure out this hypotenuse. 8 squared is equal to 6 squared plus 8 squared. So that gives you h is equal to 10. So the perimeter, therefore, is 10 plus 8 plus 6, which is 24. So if you have a square and its perimeter is 24, then that means each side is equal to 6. And they want you to figure out the area of the square. Well, the area is 6 times 6, which is 36. So number 16, the answer is D. The perimeter of ABC is 32, angle ABC equals angle ACB, and BC is 12, the length of AB is. This angle is the same as that angle, and therefore that side will be the same as that side, making that an isosceles triangle. The perimeter is 32, so if this side, let's say, is y, and that side is y, that means that 2y plus 12 is equal to 32. So solving for y, we get 2y is equal to 20, and therefore y is equal to 10. And AB is equal to y, so therefore AB is equal to 10. So number 11, the answer is C.